You're listening to the TES Maths Podcast with Craig Barton.
Hello and welcome to episode 3 of the TES Maths Podcast with me, Craig Barton. In a Christmas cracker of a show, we will bring you mathematically themed news, discussion and resources that will hopefully be of interest to teachers and general number enthusiasts all around the world. And I am delighted to say that this week I am joined by not one, but two very special guests. And more than that, they are a professor and a senior research fellow. So I'm feeling very intimidated indeed. They are Jeremy Hodgson and Dietmar Kuschelman from King's College London. Hello Jeremy and Dietmar.
Hello.
And thanks so much for taking the time to join us today. And they are here to talk about the ICC AMS project and its accompanying activities that seeks to help improve students' engagement and understanding in key areas of mathematics. And just a reminder that you can find the links to all the resources and ideas mentioned throughout the show on our website. That's www.tes.co.uk/mathspodcast. And if you're not already doing so, and why on earth would you not be, please follow me on Twitter at TES Maths for daily resource recommendations and much more. Hopefully that's whetted your appetite, so without further ado, let's get started. For our news section this week, I want to return to an article that caught my eye from the TES magazine back in late September. And I'm going to read the headline here, "What a Difference 30 Years Make, None in Maths." And it's an intriguing article, and what's the best bit about all this is one of the people quoted in it is none other than my special guest here, Jeremy. So I'm going to quote one of the paragraphs from it, and then I'm going to get Jeremy's take on it. So here we go. "The proportion of pupils who understand algebra, ratios and fractions at the age of 14 has fallen since the 1970s, while the proportion who struggle with even the simplest concepts has increased. The findings are in contrast to the number of pupils gaining grade C or above in Maths GCSE, which has risen every year since the exam was introduced." So, Jeremy, could you give us an overview of the main findings from this study, if that's all right?
Well, what we did was we repeated some tests that had been used in the 1970s, and the tests were in algebra, in ratio, and in decimal numbers. And we used exactly the same tests. We repeated that with a national sample, and we found that the proportion of students at the very top end had reduced, particularly in algebra and ratio.
Okay.
And we found that the proportion of students at the very bottom end had increased.
Right.
So, for example, in ratio, the proportion of students at the very bottom end had increased from 7% to about 15%.
Okay.
A massive increase. Now, what does that mean, of course? What does that mean? Well, those are students who are really struggling with even the most basic concepts of ratio.
And we're talking kind of simplifying ratio, or just a general understanding of what ratio...
Just seeing things as doubling.
Really?
Or halving, or trebling.
Sure.
Not coping with complex ratios. Of course, this test wasn't simply a test of procedures.
Yes.
It was really a test of do students see problems as involving ratio?
And well, this fascinates me because who's to blame for this? Are the students getting weaker? Are the teachers not teaching it properly? Is it the curriculum? Is it the exams that teachers are teaching towards? I mean, what's your take on this?
We didn't look at the reasons
Okay.
in our study. I mean, our study just compares attainment then with attainment now, and the reasons are complex. It may be that schools and teachers are being incentivized to focus on the CD borderline.
Yes.
And of course the students at the very bottom end will lose out then.
Absolutely.
Because they're not at that point. And similarly, those at the very top end may lose out from that. What would your take on it be? Dietmar?
Well, I mean, it's worth reminding ourselves we are talking about the extremes that have changed.
Yes,
In the middle,
yes.
it hasn't changed particularly. It's
That's
really very
interesting.
similar to 30 years
Mm.
ago, I think, for the sort of average student, perhaps. I mean, one of the things, we looked at textbooks, which was quite an interesting exercise. We looked at the old S&P letter series
Yes.
and some current textbooks, some of the more popular ones. And one sense we had was that the older textbooks were more mathematical. They addressed the teacher in a more mathematical way. The teacher's guides
Yes.
were more thoughtful and extensive.
And is that the same in the exams as well? Did you notice?
We have looked at the exams, haven't we? We haven't quite finished that work, but
What's your kind of initial impression?
well, it's quite subtle actually, because superficially, the old exams look a lot harder.
Yes.
On the other hand, once you start looking at them more closely, there's quite a lot of routine there too. So
Okay.
you start spotting question types, and so I imagine just as now one can teach to the exam, one could have taught to the exam in those days. So even though superficially they look harder, if students are taught how to do them.
So we can, in a sense, rule out the exam.
Well,
one of the
we may.
causes.
It may not be as big a difference as it looks on the surface.
Because I
There may
think
still
that
be
would be a
difference.
lot of teachers' first instincts. I would have thought that the exams 30 years ago were more difficult, so students needed more rigour, more understanding.
Well, I think if you gave a current child those exams,
Yes.
they would find them more difficult.
Right,
So
okay.
that doesn't mean that they were more difficult for the children of the 70s
understand.
necessarily.
I see.
Although, I mean, the language was more complex.
You have to remember that students in the 70s didn't all take the exam.
Yes, no, that's very true.
So I mean, only about 25% were taking
So-
taking the O-level exam, and not all students were taking the CSE exam. Many of them might have been taking some. Many of them might not have left school. Might have left school without any examination.
So if that's the case, are we saying it's not actually that big a problem then?
It's an enormous problem. I mean, the project is part of a bigger program that's looking at attainment and participation in science and maths
Yes.
and STEM subjects more generally. Now, if you're going to go on to science, you need ratio.
Yes.
You need to understand the multiplicative aspects of decimal number. You need to see problems involving ratio, and you need algebra. You can't do those subjects without those things. And actually, if you're going to use, even if you're going to use a calculator, you need to see problems as involving ratio.
Okay, and the tasks and activities that you've kind of designed as part of this project will hopefully address some of these problems.
Absolutely.
If you were thinking of turning off your podcast, stop right away, because we're going to be discussing some of those later in the interview. So that's fantastic. And as it is the season of giving, I thought we would try and squeeze in one more little item, and that's a discussion that I started on the TES Maths Forum about what should happen in maths lessons during the last week before the Christmas holidays. Now, opinion among teachers seems to be very much split on this. Some cannot wait to stick on Dynamo or Toy Story 3, and others like to keep students simplifying fractions and expanding brackets right up until that final bell. If, like me, you are somewhere in the middle of these, then hopefully the following suggestions for Christmas activities that are both fun and mathematical might be of interest. The first one links back to the guest that we had on last week, and that is Enrich's amazing advent calendar. Now, each year they bring out one of these, and what is better than finding a chocolate treat behind your door than finding a mathematical puzzle behind your door? So they have 24 wonderful rich maths activities, and what I do with my Year 8 class is we crack open one of these each maths lesson and try and solve it for the first 10 minutes of the lesson. They are wonderful starters, wonderful extension materials, and have a Christmassy theme to them. And following on from that, TES Maths panel member Mr. Collins has his own version of an advent calendar that he gets his Year 7s to build, where they set each other problems, and he's very kindly uploaded that to TES. And just like anything else that I mentioned today, you'll find links to all that on the podcast page. So they're 2 little Christmas activities to get you going. And if that wasn't enough, then how about the classic pirate game? Now, my kids are going absolutely crazy. When I introduced this to them last year, all they ever talk about now is when can we play the pirate game again. And it is both mathematical, fun and challenging. And if you want to know more about that, then please click on the link and you will find out more. And also we have the slightly grimly titled Who Killed Santa Claus? And that is a lovely mathematical mystery with a bit of a dark edge to it that your kids may well respond to. So please check that out, and that should keep you and your students very busy right up until the final bell when we can all go home for our Christmas holidays. So that is in the news this week. For Show and Tell this week, we take a look at the minefield of misconceptions that is negative numbers. Now, this is a topic that it never ceases to amaze me how many problems students have with it. And it just so happens that I was testing out a problem that I was going to mention on this podcast with one of the employees of TES, whose name will go unmentioned. And I set her a problem, and even she got it wrong, because the question she asked me was, that minus in front of the 3, is that a minus or a takeaway? And I think this is one of the hardest problems with it, that students don't understand the difference between a minus, a negative and a takeaway. And then you've got the absolute classic problem that students chant it, well sir, 2 minuses make a plus. And it's the most misapplied rule that you can have in mathematics, and it leads to a whole world of problems. So I'm going to just have a brief chat about how I teach negative numbers and how I introduce it. And the first thing I do is I ban the use of the word minus, and I only talk about negatives and takeaways or subtractions, because I think that straight away removes a little bit of the confusion. So I'm going to introduce the way I do it, and I'm going to do this live with Jeremy and Dietmar. Now, we haven't rehearsed this, so anything could happen. Now, I teach negative numbers using a bowl of soup. And what I do, and I'm going to try this on Jeremy first, is I want you to imagine a bowl of soup that starts off being 12 degrees warm, 12 degrees centigrade warm. And into that soup, I can either put in ice cubes, and each ice cube reduces the temperature by 1 degree, or I can put in fire cubes. And you've got to suspend your disbelief a little bit here, because fire cubes raise the temperature by 1 degree. So we've got ice cubes that take 1 off, and fire cubes. One of my year 8 students suggested using chilies instead of fire cubes, because that makes more sense. But he said he'd charge me £1 every time I use that. So to save me a bit of money, I'm sticking with fire cubes. So here's your first problem, Jeremy. You've got your soup, it's 12 degrees, and I'm going to put in 4 ice cubes. So I'm going to add in 4 ice cubes. What is the new temperature of the soup?
8 degrees.
8 degrees. Now, the beauty of that is if you introduce it in that context, you can then write on the board 12 plus negative 4. 12, add in 4 ice cubes. 12 plus negative 4. And students aren't learning a rule there that a plus and a minus next to each other equals a minus. They're actually understanding why it works. So I like doing that when you've got that kind of question. Now, Dietmar, you get a trickier one, okay?
I struggle with the first one.
So this time, your bowl of soup is a chilly bowl of soup, okay? It's about on the nippy side. It's actually minus 3 degrees, okay? Negative 3 degrees. And this time, I'm going to take out 2 fire cubes. So it's negative 3 degrees, and I take out 2 fire cubes. What's the new temperature of that soup?
Okay, well, I've written these things down to help me. I think it's -5, or rather, sorry, -5.
Negative 5. And I agree.
Sorry,
Oh, you're all right, Dean. I'll see me at the end. And I completely agree with that. And what's nice there, you've got -3, take away +2. And that, if you give that question to your students, certainly my year 8s, when I gave them that at the start of the year, they were like, well, sir, there's 2 minuses, so 2 minuses make a plus, so it's going to be 5, or I heard 1, and all this kind of stuff. But no, forget that rule. Just put it in this context, talk it through, and you'll get the correct answer of -5. And now comes the big one, the one that they always get wrong. And here it comes to Jeremy. All right, here we go.
So I get the hardest one.
Exactly.
I'm still wondering about this frozen soup.
Well, here we go. I've got a slightly warmer bowl for you now. So it starts off at 3 degrees.
Right.
And I want you to take out 4 ice cubes. What's the new temperature of the soup now?
Well, I reckon it's 7.
I reckon it's 7 as well. Now, what we've got here, we've got 3, take away -4. So here you have got 2 minuses that equal a plus. But the students don't need to know that. They just need to say it in that context, and then they understand it, because they had 2 minuses in the last question, but that wasn't a plus. And I think as soon as you start giving students rules, they start misapplying them and misremembering them. But if you can explain the context and get them thinking it through, they're fine. So 3 take away -4 does indeed equal 7. Now, Jeremy and Dietmar, what's your take on negative numbers?
Well, I suppose what I like about your example here is your use of, I'm going to get it wrong, is it -4? It's -4.
That's perfect.
Reflects 4 as the additive inverse.
Yes.
So you've got directional number in there. What I like less about it.
Okay, here we go.
is how this is thinking about how this translates into multiplication.
Yes.
Which is, of course, what we're
Absolutely,
really
yeah,
interested
absolutely.
in. And I'm not sure it does translate very well.
No.
Because you haven't got a real 0.
Yes.
Because 0 in terms of temperature is a kind of arbitrary
Okay.
0, and it's looking for examples where you get well, I mean, what examples do you get where you get -1 multiplied by -1?
That's the thing. I mean, because I would argue that you can do, say we had 3 multiplied by -4. I think you could make a case using this that if you've got 3 lots of 4 ice cubes, they have the equivalent impact of a -12, a -12 reduction in temperature. So I agree with you. I think you're absolutely fine when you've got a positive multiplied by a negative to explain why that's a negative. But yeah, I'm yet to come up with a decent example of why -3 times -4 equals +12.
Well,
Now,
I think
this could be life-changing for me, because Jeremy looks like he's onto something here.
Well, I think this is where science helps us.
Okay.
Because of physics has lots of examples where you have negatives times negatives is a positive.
Right.
So what was it?
-3 times -4. Why does it equal +12?
Okay, so something travelling backwards at 3 meters per second.
Okay.
Where was it 4 seconds ago?
Oh, that's nice. Yes, I like that.
But when we ask our teachers on our PGCE course, and they are mathematically very strong.
Yes.
So we've always got some people with firsts from Oxbridge,
Right.
Imperial, Warwick. When we ask them why are 2 negatives a positive, what do they say? Nothing.
Nothing.
And then someone pipes up with, "Well, my teacher told me."
Yeah.
And if people who are good mathematically are finding it difficult to explain,
Absolutely
we've got to
right.
take it on in terms of dealing with that problem all the way through. I think.
mean, part of me thinks, does it matter? I mean, do they for year 8 low ability students? Can you make the case that as long as they remember -3 times -4 is +12? If you're saying that Oxbridge first candidates don't know why, are we asking too much that they should know why?
Well, I think in primary school, you could make use of directed number more, couldn't you?
Yeah.
And I mean, in terms of an image of multiplying by -1 as a kind of flip is quite a nice and accessible image. I mean, I think that's accessible to almost everybody.
And I'm very pleased to say that since I wrote a little article about this in the TES magazine, the wonderful users of the TES website have produced some amazing resources to go along with it. So TAFCAM has come up with one that involves a cauldron and a bit of Harry Potter in there, because Severus Snape is chucking in ice cubes and fire cubes left, right and centre, and it's a lovely PowerPoint that goes down a storm with students. And also Gemma Calderwood has created some worksheets to accompany a lesson that uses the fire and ice cubes, and links to both of those are on the podcast page. So, as you know, I'm very fortunate to be joined by Jeremy and Dietmar. And my first question to you both, and if we start with Dietmar first perhaps, is how did your interest in mathematics start?
I think I found that at infant school I was relatively good at it, even though it was just arithmetic, I think. My granddad, my father's father, was a maths teacher, so maybe that had an influence, even though I hardly knew him.
And how long did you teach for?
I think it was 7 years.
Okay.
And nice bit of serendipity, actually. One of my colleagues had trained at Chelsea College, as it was then, and he was going there one evening. I couldn't understand why anyone would do that after a hard day's work. But I went with him and discovered Chelsea College, which was near to where I lived, and did an M.Ed there, and then got onto the CSMS research, from which we've used these tests in our current work.
And do you miss being out of the classroom?
Well, I think the nice thing is that in this project in particular, I've been in the classroom a lot, and it's been absolutely wonderful because I've been privileged to see other people teaching, and been allowed to do a little bit of teaching myself with them protecting me, controlling the class for me. And we've done some wonderful work where we've been able to interview small groups of students, and it's been absolutely delightful. So we've had the best of
both worlds,
being in the classroom without all the responsibilities. All the stress.
And no marking as well.
No
That's
marking.
very good. How about yourself, Jeremy? Where did it all start for you?
I had a very good maths teacher at school in my later years at school. I did a maths degree and wasn't sure what to do, so I started teaching.
But a lot of people just fall into it, don't they? And how long did you teach for?
I taught for 7 years as well.
7 years,
yeah. So I taught first in secondary schools and then in primary schools.
And how long into that 7 years were you thinking, I want to do something different, I want to go into more kind of the academia side of things?
I applied to do a PhD at King's towards the end of that towards the end of that 7 years, and met Margaret Brown, David Johnson, and the rest is history.
It all went from there. That's fantastic. So, for people who haven't heard of the ICC-AMS project, Dietmar, would you care to just summarise what it's all about?
Well, it has these two phases, and Jeremy's in a way talked about the first, where we did this large-scale survey of comparing 30 years ago and now. And the second phase was trying to develop some materials in we thought the two crucial areas of secondary maths, or mathematics as a whole, of algebra and multiplicative reasoning. And
what made you choose those two? Why did you feel they were the most important?
Because of the fundamental ideas in terms of going on mathematically, and in terms of what you might use mathematics for. In terms of algebra and multiplicative reasoning, everybody needs to understand multiplication. Everybody.
Yes.
If you're going to cope with any sort of idea of risk,
I agree. Yeah.
or you need multiplication. In terms of algebra, well, everybody needs a chance to understand algebra, so they can choose whether to go on to science or subjects that need algebra.
Could you make the case that of more practical use to students would be to focus on something like data and statistics, which may occur more in their everyday lives than algebra would be?
But we ought to study data and statistics, and of course you can't do data and statistics without multiplicative reasoning. Actually, you can't do them without understanding structure, and algebra is more than symbols. I mean, actually, symbols, as we all know, are very powerful.
Yes.
But really, algebra is about understanding the structure of number and understanding aspects of generality. Okay. Those you need for statistics in order to do any statistics. And actually, that's where algebra helps you with multiplication. Thinking about the relationship between multiplication and addition is central to thinking about algebraic structure, and therefore. That's why you need to do algebra.
You've sold me on that one. So you've done the research into the project, and then have you devised the materials first and then gone out to test them, or have teachers been involved in the development of them? How's that worked?
We involved teachers very closely. well, we had a small team of teachers, first of all, with whom we did the development work, and they spent one day a term with us, and then we would visit them in school. So they had quite or was it 2 days a term, wasn't it?
It was 2 days.
2 days a term.
days
It was actually 6 days in that first year, which is quite a lot of time
Yeah.
out of school. And these were pairs of teachers in their school, so
Okay.
they could also interact back in their schools. So they had quite a strong input, although possibly not as strong as we had originally envisaged. I think quite
Right.
a lot of the stuff in the end came from us, and then they would help us modify it.
Okay.
They would try it in their classes or allow us to
Sure.
try it sometimes.
And I should say at this point as well that Dietmar and Jeremy have been very kind and actually let us share some of these on TES, and the links to the activities and starters they've shared will be available on the podcast page. So I would imagine, I mean, have you found this, that teachers have been a little resistant to try and deliver lessons this way because it's something that they're not used to?
I think they've been quite positive about trying the starters in this way. I mean,
Yes.
it's taken time to develop, but I think because the starters are short, or in theory they're short, sometimes they actually run across a whole lesson. But they're prepared to kind of try something and then move on.
I mean, the thing is that these lessons are quite exciting.
Oh yeah, oh no, absolutely.
And they're, I mean, it is, as a teacher, it is exciting to have a situation where the students are doing some mathematics. I mean, they're doing some mathematics where they're having to talk, they're having to argue. I mean, as you say, you'll have a range of different ideas in the class. Usually, no one will have no idea,
Yeah.
and no one will have quite got everything. So everybody gains. And what the lessons do is they kind of provide a kind of structure for the teacher to do that. So in a sense, of course, you are, as you say, entering into the unknown, but it's a kind of structured unknown. It provides some structure in order that you can engage with that discussion and allow the students to do some maths, which is actually what we want them to be able to do.
Oh, absolutely. And what kind of type of students are we talking here? What age and what ability? Because again, I'm thinking teachers may well be thinking, this is all well and good with my top sets who probably run with any idea they're given, but if I've got a middle ability class who perhaps aren't used to discussing things mathematically, who prefer a rigid structure, here's an example, now you try one. Does it work with those classes as well? Have you seen evidence that this can work with the full range of abilities?
I mean, you've got to do different things with different classes. Written lessons never describe how
Yeah.
teaching is. I mean, teaching is a difficult, complex job, and so the teachers that we've worked with have done different things in different classes. So in a sense, students need some experience of talking. It's quite difficult to talk mathematically.
Absolutely.
You're not used to articulating some of the ideas. You're not often asked to explain. I mean, explaining why this is why something is multiplicative.
I mean, it's very difficult for us to explain it. So a year 8 student, but it's such an important thing. But it's very, very difficult.
So and teachers have found that in some classes they've needed to give the students little bits of time to talk,
Yes.
and gradually they can build that up.
Yes.
And in some classes, the students are well used to talking, so they can give them longer. But they've worked with all types of classes. Have teachers found it difficult in places? Yes.
Yeah.
Of course,
Absolutely.
it's difficult. That's in the nature. We know mathematics teaching is perhaps the most difficult bit of teaching,
To think so, yeah.
and therefore, you're going to encounter difficulties. But it's exciting to get kids talking about maths.
Definitely.
I think one of the interesting things, and it surprised a lot of teachers and possibly surprised us, I don't know, is they would look at a lesson outline and say, well, this is only going to take 10 minutes.
Yeah.
and it would take more than one lesson.
Yes.
Because these rich ideas came from the students, and it wasn't simply a matter of practicing an exercise.
I mean, it does take quite a high level of teaching skill, doesn't it, to coordinate the discussion, to keep the students going. You can almost understand why teachers would prefer the more structured lessons, but as you say, it's exciting. It's scary, I think, to deliver one of these lessons, certainly for the first time. But there's a lot more learning going on, isn't it? The students are playing a larger role in the lesson. They're certainly not passive.
No, they're not passive. And in many of these lessons, there's an opportunity for the teacher to remember what was difficult about mathematics. One of the key ideas, as Dietmar said, is this idea of formative assessment. You know what it's like when you learn a mathematical idea. When you haven't got it, it's completely alien.
Yeah.
And then suddenly, when you have got it, you think, why was it difficult?
Yeah.
And it's so difficult to remember what students will find difficult. And that's one of the things that we've tried to do in the starters, is to throw up the difficulties that students will have, the ways they think about the problem, in order that the teacher can then listen to what they're doing and try and remember what was difficult. And therefore, once you remember what's difficult, you can start to think, well, how am I going to explain that? What questions am I going to ask? And the lessons provide some of that, and some support for the teacher in doing that.
I want to ask, what impact are you hoping this project will have? What's the kind of dream? Do you want this to be taught in every school? It forms every part of the Key Stage 3 scheme of work. What are we hoping for? One
of the criticisms of formative assessment was that it was very generally described.
Yeah.
So everybody's heard of formative assessment, haven't they? They've heard of no hands up.
Yeah.
They've heard of traffic lights. But actually, if you're going to use formative assessment in mathematics, you need to use it mathematically.
Yeah.
So we wanted some descriptions of how formative assessment could be used, and that's what the lessons do. These are still trial lessons.
Sure.
They're still at the stage of experiment and trialling. We've got them up on the website. We'd love to hear from teachers about whether they've worked, or more importantly, what hasn't worked,
Yes.
because that's always the useful bit for us. But I mean, we hope that teachers will find these useful. We hope that more teachers will use them. We hope that they'll exemplify ways that make it useful for teachers to use formative assessment in the class. And we hope that it will help teachers figure out understanding.
Yes.
But I mean, at the moment, it's quite small. It's quite at a small scale. And I mean, we're not interested in taking over the world as that.
Aren't you?
Maybe Dietmar is.
And what's the kind of end of the project? What kind of timescale have you got on this? Is there a point you're going to reach where you're going to say, right, we've got all the feedback, we're going to get on this, these are the final versions of the activities, end of, and now I'm going to move on? Or is it an ongoing thing?
Well, it'll be an ongoing thing. But the next stage of the project, once we've got some feedback from teachers who haven't been involved in the project, the next stage will be to do a proper trial with a group of teachers that we haven't chosen, or who haven't self-selected, as it were, and we'll hope to do that in the near future.
That's fantastic. And if any of our lovely podcast listeners would like to trial these resources out, as I say, they're available on our podcast page, and I'm sure Jeremy and Dietmar would love to hear your responses to them, and I'll put their email addresses on there as well. Well, we've reached that time of the podcast again where we challenge our listeners with a podcast puzzle, and I'm delighted to say that we have one from Dietmar this week. So Dietmar, over to you.
Okay, this is an Argos special offer that's not exclusive to Argos, I'm sure, but they have an offer where they say spend £50 and get a £5 voucher, and the question simply is, what is the effective discount that you're getting from this offer? So if you do spend your £50, you do get your voucher. What discount, in effect, have you been given?
Oh, what we look at, percentage discount?
Yes, I would say percentage discount.
What percentage discount do you get from that Argos offer? So feel free to discuss that one in the podcast thread on the forums. Thank you, Dietmar. So we have reached the end of yet another TES Maths podcast. All that remains for me to do is to thank Jeremy and Dietmar so much for coming in and sharing their wonderful insights, and I hope you'll enjoy downloading and using their excellent resources. So thank you so much, Jeremy and Dietmar.
Thank you.
Next time, we will hopefully be joined by one of my mathematical heroes, Malcolm Swan, the man behind the all-time classic Improving Learning in Mathematics resources, and much, much more. And just a reminder that you can find the links to all the resources and ideas mentioned throughout the show on our website. That's www.tes.co.uk/mathspodcast. And if you're not already doing so, then please follow me on Twitter at TES Maths for daily resource recommendations and much more. And all that is left for me to do is to wish you all a happy and safe Christmas and New Year, and I will see you in 2013. Bye for now.